Can you just give a quick brief?
For which chapter?
Force and pressure. I
Okay,
was actually traveling that week, so I couldn't really attend all the classes.
okay, okay, fine. So this
Sir, I
time I'm
also did not attend those classes. So last week was my first class in physics.
okay, okay, okay. So here I'm providing a quick brief to all of you. And also do remember the recorded videos are available of all the classes.
Yes, sir.
Okay, just check out if the screen is visible to everyone.
It is, sir. Thank you.
Yes, sir.
Okay. Anyone having any voice problems?
No, sir.
Okay, let's continue now. We are having with the revision of force and pressure. Since most of you are going to have your exams just in the month of July, so we are having a revision for force and pressure. Okay. So in this chapter, force and pressure, let's see what do we know, how do we define force. Also, if your cameras are on, so you are the first one to appear, and if any questions or if any queries are there, I am going to ask only you. Okay, so keep your camera on to be an active participant. If you keep your camera off, so you will become passive. So force and pressure, we define force as an interaction between two bodies, or we define force as a push or pull. So in simple terms, we can say
Sure.
a force is a push or pull. So
Acting on an
whenever
object.
yeah, push or pull on an object is called pressure. It's called force. So a push or pull can be in different ways. So whenever you are applying a push, you are trying to push an object, you are trying to pull an object, so you are applying a force on an object. Okay. So what are the changes that we see when we apply a force? When we
The
had seen what are
direction,
Sir,
changes that yes.
the
sir, may I?
direction, shape.
Sir, when we keep the effort, when we keep a force on an object, state, shape, color, motion, direction, and
Mhm.
The shape.
yes,
Shape, okay.
state
So
and color,
color,
not color, sir. Shape, shape and
shape. Okay. So state of motion, direction of motion, it can change the direction of motion, it can change the state of motion, it can change the shape of an object.
They're
Okay.
moving at
So
consistent velocity.
uh, actually talking in terms of physics, we do not require any force to to be moving with a consistent velocity. If you want an object to be moving with consistent velocity, there is no requirement of applying a force on it.
Okay, sir.
Okay. So see what the force can do. It can change the direction of motion of an object, or it can change the state of motion of an object. State of motion means when I say state of motion, so it can bring an object from rest to motion or an object from motion to rest. If an object is moving, it can stop it, it can increase or decrease the speed, increase or decrease speed.
sir, it can also change the state of the object, like state in meaning like liquid, solid, or gas.
What type of state?
Like if it a physical or pressure could change, the force could change like the solid to a liquid. Regarding the physical contact.
No, no. Can you give any example where force can change the state from solid to liquid?
No, sir, I think that's for different thing.
Yeah.
Physical
So
change.
yes. So we are talking a state of motion, that is rest or moving. If an object is at rest, it can bring it in motion. If an object is moving, so it can bring it in the state of rest. It can increase or decrease the speed of an object. it can change the shape of an object. So shape of object can be changed. Right. So after this, we had done about the balanced and unbalanced forces.
Balance force.
So what are balanced forces?
Sir, I have doubt in these only, sir. Balance and unbalanced.
Yeah.
Sir, I have doubt in these only, sir. Like unbalanced and balanced forces.
Okay. See, whenever a number of forces are acting on an object, if you have an object and on that you have a number of forces which are acting. So if a number of forces, suppose I have this object and on this object a number of forces are acting. So suppose here I have these two forces which are acting on this object. So if the two forces which are acting on this object, they are equal and opposite. So here I have equal and opposite forces acting on the object. Let's say this is our force F1 and equals to 10 Newton of force. And say here also you have a force F2 equal to 10 Newton of force. So as we observe here that both the forces, they are equal and opposite. So can I say that their net sum will be equal to 0?
Yes, sir.
Yes, sir.
Yes. So here net sum of these forces will be equal to 0. If I add the two forces F1 plus F2, the two forces will be added up to 0. Since one of them is towards the right, the other one towards the left. So net force here is 0 and hence we say that these forces are balanced. Okay.
Sir,
So
any
if
Sir,
we
but
get
does
the, yes,
sir, do the balanced forces have to be opposite to each other?
yeah, in the balanced forces, of course, if there are some forces on one side, then there have to be some forces on the other side.
No, so for example, what if the force applied on the thing is applied in the right angle way?
Okay, okay, something like this you are talking. If you have a force acting like this and a
Sir?
force is acting like at
Yes,
right
sir.
angles.
Yes.
Okay.
And
So-
then
Sir?
both of them have 10 Newton.
Okay, both of them are 10 Newton force. Okay.
So will
So for
that
such,
count as a balanced force?
yes, pardon?
Will it count as a balanced force?
No, it's not balanced force. They are
So
unbalanced
balanced force should
forces.
always be opposite.
Yeah, they have to be opposite. You will get, see, it's something like this. You have this object and there are two people who are trying to pull it. They are trying to pull it perpendicular to each other. So do you think that the object will be moving something like this? The object will be moving in the diagonal situation. It will be moving
Sir?
towards the diagonal.
Sir, balance force means like the both sides where the force is applying should be same, sir.
Yeah, both the sides, the forces applying should be the same.
Okay, sir.
I
It
have a
can be,
doubt.
yes.
So I'm sorry to disturb, sir, but when the balanced forces are there, the both of the opposite sides should be like there should be only in opposite directions, sir.
There are different situations where even if they are not in opposite directions, they can be balanced. Okay, but that's not as a part of your syllabus. Something like this can happen.
Sir, like my
Uh,
mom even thought
Yeah,
like
yeah, it can happen. Suppose if you have three
from
people,
what
it's not necessary that there have to be two forces. Something like this. Okay,
yes,
so
sir.
if you have two people pulling like this and one person pulling like this. So then also the forces would become balanced. But how they will become balanced, that is not a part of your syllabus.
Okay.
Okay. So
Like
that's why I
from
don't.
all the three directions, it should be same Newton force. So that's
Yeah.
why the object will be balanced. Means it will
Yeah.
be stuck to one place.
Yeah. If there is same amount of force acting in all the three directions and they are making an angle of 120 degree here. So it should be an angle of 120 degree with each. Okay. There are different situations possible, not only this. There are different other situations are possible, which you will be coming to know in your grade 11.
Sir,
Okay, so
like
in grade,
even if there is a box, like heavy box, two persons are pushing in the same direction means Also, it is a balanced force, right? So with the same Newton force.
If they are pushing it in the same direction, then the forces can't be balanced. Then the forces are unbalanced.
Sir, will
If
tug of war come under balanced forces?
uh, tug of
War means two
yeah,
two people
tug
pulling.
in the case of tug of war, every time it's not balanced. Okay. So when the forces from both the sides are equal, then it's balanced. If the forces from both the sides is not equal, then the forces are unbalanced.
Okay,
Okay.
sir.
If the two teams are applying the same amount of force, then it will be balanced. If one of the team applies a greater force, then it will become unbalanced. Okay. So I think this is clear about balanced and unbalanced forces. Whenever you have a number of forces acting on an object such that their sum is equal to 0. If the sum of the forces is equal to 0, the forces are balanced forces. So balanced forces, they can change the shape of an object. For example, if you take a balloon, you press it from two opposite sides. So if you press it from two opposite sides, the forces will be balanced and hence you will observe a change in shape of the balloon. Okay, there will be a change of shape of the balloon. So now these are balanced and unbalanced forces. Now after this, we had seen contact and non-contact forces. Contact forces and non-contact forces. So what are contact forces? When the contact forces, they are the forces which act only when
So I
forces
have
which,
one doubt.
yes.
So back in the balanced force, the
Hmm.
balanced force, if it's not a pull and if it's a push, it can change the shape of the object, right?
Just pardon again, Srishta.
So basically, in the balanced force, instead of two people pulling an object, what if they
Yeah,
push the object inside with the
yeah, then
equal amount of force?
then also it is a balanced force. Okay.
No, sir. The shape of the object changes, right?
Yeah, the shape of the object will change in both the cases. If you pull it or if you push it in both the cases. For example, if you take a case of a rubber band, okay. So if you take a rubber band and if you stretch it, so by stretching a rubber band, you are applying equal and opposite forces in opposite directions, and hence this length of the rubber band changes. It increases. And if you take a case of a spring, so for the case of a spring, if you apply pull forces on both the directions, the length of the spring will increase like this. And if you compress from both the directions, if you apply opposite force, compress it, so you will observe the spring to be shortened like this. Okay. So
Yes, sir.
in both ways, there will be a change of shape. Either it is a compression or it is a stretching. Okay. Any other doubt? Okay. Okay. Just 1 minute. Just hold on for 1 minute.
Sir, is this the last lesson?
Okay. So about balanced and unbalanced forces. See, what are the balanced forces and what are unbalanced forces we have seen. Balanced means if you add up the forces, their sum becomes zero. And balanced forces, they can bring about a change of shape of the object. Whereas if the forces are unbalanced, they will bring about a change in the state of motion of an object. Now we're looking for contact and non-contact forces. So those forces, contact forces and non-contact forces. So forces which act only when two bodies are in direct physical contact with each other. Contact forces which act only when two bodies,
Teacher
two bodies
are in
are,
contact with each other.
are in direct physical contact. So we are talking of physical contact.
So can I say
In that,
examples of them?
direct physical contact with each other.
Um,
Okay.
muscular force
Yes.
and frictional force
Okay. So these are the two examples.
of
Muscular
contact
force.
and
Okay,
frictional.
muscular force and frictional force.
Yes, sir.
So muscular force and frictional force, they are the examples of contact forces. Then you have non-contact forces. So non-contact forces are the forces which act when two bodies are not in a physical contact.
Yes,
So
sir.
they can act without physical contact.
Physical contact.
So for examples for these are gravitational
Magnetic
forces.
force,
Okay, you have
electrostatic forces.
magnetic force. You have electrostatic.
Electrostatic
Yes,
and
magnetic,
gravitational force.
electrostatic, and
Gravitational.
gravitational. Very good. So magnetic forces, gravitational forces, electrostatic forces, these are the forces which are non-contact forces. They can act even when there is no physical contact between the two bodies. Even when there is no physical contact, so we can observe that these forces act. So such forces, they are the non-contact forces. For example, whenever we see, okay, let's see this. So suppose you have some fruits or some substances falling on the surface of earth. So is there a physical contact between earth and the substance which is falling? So you have any substance which is falling on the surface of earth.
There is no contact force, sir. It's a non-contact force.
Okay. So all the objects which are in the atmosphere or around the earth, they are attracted towards the earth. They are attracted towards the center of the earth without any physical contact. Okay. So how is the moon attracted towards the earth?
So by gravity.
Gravity, the gravitational forces. Okay. So it is the gravitational force of the earth which holds the moon towards itself. Okay.
They
So
attract each other.
they are, yes.
How gravitational force forms, sir?
How gravitational force
Form.
form.
How yes, sir. How the energy.
Okay. See, to explain the concept of the non-contact forces, there have been different ideas, there have been different strategies to explain them. One of the concept is the field theory. So these are the two concepts, either the field theory or the particle theory. Okay. So the field theory,
Sir, what is
yeah,
the field theory again?
I'm telling you, these are not a part of your syllabus, but still I'm telling you a little bit only. Field theory means it tells that whatever substance is there, it first creates a field around itself. So for example, if we have earth, Earth has created a gravitational field around itself. Now, whatever substance will enter inside that field, it will experience a force. Okay, so it is gravitational field. You have a gravitational field, and everything that enters in that field will experience a force. Okay, so this is the concept of the field theory. Then you have the next theory is the particle theory. The particle theory states that there are very tiny particles which are exchanged between them, which cause, due to the exchange of the particles between them, there can be forces of attraction or repulsion. Okay, so these are the two concepts, the field theory and the particle theory. Currently, we are mainly working on the field theory, where we assume that around the Earth has created a gravitational field. Okay, and whatever substance will enter the gravitational field, it will experience a force towards the Earth. Okay, so it's the similar for the electrostatic also. For example, if you have a positive charge, okay, you have a positive charge, and so the positive charge creates a field around itself. It has created a field around itself. Now, if any positive charge enters in this field, so this positive charge will experience a repulsive force, whereas if there is a negative charge which enters this field, so this negative charge will experience an attractive force towards the positive charge. Okay. Yes, and last year.
Yes, sir. Sir, in gravitational force. Sir, am I audible?
Yeah,
Sir, am I audible? Yes,
yeah,
sir.
you are
Sir, in
audible.
gravitational force, yes, sir. Sir, in gravitational force, two objects attract each other. Like they come closer, attract each other, and in
Yeah.
electrostatic force, they both get repel each other.
See, gravitational force, they are always attractive, only attractive in nature.
Okay, sir.
They cannot be repulsive. Whereas the electrostatic forces, they can be either
Only
attractive.
repulsion.
No, they can be either attractive or repulsive. They can be both.
Okay.
For example, if you have two similar charges, if you have two positive charges, so the two positive charges will repel each other.
Yes.
Okay. If you have two negative charges, they will also repel each other. But if you have a positive charge and a negative charge, so they will attract each other. Okay.
Yes, sir.
So the electrostatic forces, they can be either attractive or repulsive. You can either experience an attractive force or a repulsive force for the electrostatic forces, but the gravitational forces are the forces which are always attractive in nature. Okay. And now another important thing which I am telling here, for the AITS. Okay, questions are asked depending on the gravitational forces. So the question is like this: the gravitational force between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Right? So if the two objects are very far off, they will experience very small amount of gravitational force. And if the two objects are very close to each other, they will experience a large amount of gravitational force. Got it?
Yes, sir.
Force is directly proportional to 1 by m square. What is 1 by m square, sir? Yes.
1 by r square. That means inversely proportional to r square, the distance between the two objects. So for example, if the distance between the two objects increases to double, the force between them will decrease, will become 1 by 4. Okay. If the distance between the two objects increases 3 times, the force between them will become 1 over 9 times. It will decrease as a square of the distance.
Sir,
Yes.
sir, they may even give means to find the pressure exerted by a force newtons, 90 newtons like that.
You want to say that they can be used to find out the pressure?
Yes, sir. If they give 90 newtons and tell to find the pressure.
Okay. So then you
Ha-
must get the
Having the
area of, okay. You must be
area
getting
with,
the area of contact also.
yes, sir, like 0.004 like that, meter square.
Yeah. So if you have the area of contact, we come here, just now we are coming towards pressure. Okay. Till now we are just doing about the forces. These are all forces. When we come to the pressure, we just use the formula pressure will be given by force per unit area. So force divided by area will be the pressure. Okay. We'll do this in detail when we are doing pressure just after this. Just one minute. Okay. So everyone has understood. For the AITS point of view, you have you can have a question from here. The force between the gravitational force between two
Sir?
objects. Yes,
Can you explain again about the repulsive part?
repulsive part. Okay, I'm coming to it. This I'm up to here at the gravitational forces. So, on what factor does the gravitational force depend? Pranava, on what factors does the gravitational force depend?
Non-contact force.
No, what are the factors? What are the things which
Air, sir.
control? Yeah,
Air.
no. The gravitational forces, they are controlled by the mass of
Amount
the
of matter.
object. Yeah, amount of matter, that is mass. The the gravitational force depends on the mass as well as the distance between the two objects. So something like this, if you have two objects and they are placed some distance r apart, so the gravitational force between them will depend on these two factors. It will depend on the masses of these objects and it will depend on the distance between them. Greater the mass, greater will be the force of attraction between them, and smaller the mass, smaller will be the force of smaller the mass, smaller will be the forces of attraction. Okay. But for the distance, if the objects are very close to each other, the forces will be high. If the objects are far apart, then the gravitational forces will be low. Okay. So on this basis, if I ask you a question, so which forces are greater? If we have the forces between sun and earth or the forces between sun and Neptune, which forces can be greater? Between
and
sun and
Earth.
earth, as the distance between sun and earth is less. Okay, so the force of attraction between sun and earth will be greater as compared with the forces between sun and Neptune.
Sun and Neptune.
Okay, anyone having any other doubt from the gravitational forces?
No, sir.
So the shorter the distance, the more gravitational force, right?
Yes, the shorter the distance, the more gravitational force. The greater the mass, the more gravitational force. Okay. The
So
next
then
one,
Neptune is also a greater mass than Earth. So does it not have gravitational force?
uh, about the distance is too large, and as we know that the force is inversely proportional to r squared. Square times of r.
Sir,
So
if
if the distance, yes,
sir, if the distance is 2 centimeters far, how will be the formula?
distance is 2 centimeters far.
Sir, what is
Like
R?
how
R
will
is the distance.
Yeah, r is the distance between the masses.
Okay, sir. M1 and M2 are the masses, right?
Masses, yes. And if you want the exact formula is this. F between any two objects will be G multiplied with M1, M2 over R squared. where
What
G
is
is the G is a universal gravitational constant. Its value is 6.67 multiplied with 10 to the power minus 11
Sir,
Newton meter square per kilogram square.
sir, what is R?
R is the distance between the two masses.
Okay, sir.
Okay, not to go into the much depth, this is just from the AITS point of view that you should be aware the dependence of the gravitational forces. Okay, the gravitational forces, they depend on the product of the masses and they depend as the inversely on the square of distance. Got it? Then about the electrostatic forces. Okay, so electrostatic, yes,
Sir,
yes.
substitute two. What if we substitute 2 R, sir, in the formula 1 by R square? What if we substitute 2?
Where we have two.
Like in 1 by R square formula, sir. If the particle is 2 meters, 2 meters distance from the Earth, what will be the formula, sir?
So we will use this formula. See, if you have the two masses of 1 kilogram each and they are separated by 2 meter. Okay. So you will be using this formula. You will put all the values here. You will put the value of G. You will put the value of 1, and here R as 2. Okay. So you can use this formula to find out the force between them. So it will be if
Sir,
I, yes.
but the before formula like 1 by R square you have said, no, sir. Then what is that?
So that is not the formula. That is just the dependence. It is the inverse dependence. Inverse, I hope you have understood about the inverse dependence in mathematics, like work and time. If you have that chapter you have studied about work, time and people, labor.
You have explained this formula, you have explained this inverse proportional, so, no, sir. Between
Okay.
the relation between F and 1 by R square. Can you explain
Okay.
on that?
Okay. Just this one. If you have F is inversely proportional to R square, so see what does it mean? Actually, it means if you have these two masses and they are some distance r apart. Okay. So these two objects, they are some distance r apart. And suppose they have a gravitational force F between them.
Sir, could
And
you explain
not F.
again? The formula I did got, sir, what is the meaning of,
Which formula?
like, F is equal to 1 by R square?
Okay. So this is what I am explaining here.
Okay, sir.
Okay. So what does it mean? You have two masses and suppose they are separated by some distance r between them. And during this time, the gravitational force between them, let's say, is 4 Newton. Suppose the gravitational force between them is 4 Newton. And now
R
if
is the distance.
R is the distance.
Okay,
Now,
sir.
if I increase the distance between them to r squared, if I make the distance between them as double, now the distance between them is doubled. Okay, so here, if the distance between them becomes 2r, so the new force between them would be proportional to 1 over r squared. So it should be 1 over square of 2, that's 4. 1 over 2 squared, where 2 squared means 4. So new force would now become 1 over 4 times the original force. The original force was 4 Newton. So the now new force would be, equal to just 1 Newton. If the distance is doubled, the new force would become 1 Newton, where the earlier force was only 4 Newton. Okay.
Yes, sir.
Okay. So bye all of you. See you
Sir,
again.
1 minute. Can you explain this again?
Yes.
Did not understand.
Bye, sir.
We'll get
Thank you,
to
sir. Bye.
we'll get to this in the next class. Currently, I have another class, so I need to log in at the time.
Okay,
Okay.
sir.
Okay.
Bye,
Bye,
sir.
sir. Thanks, sir.